So for this, our u would be 2x minus 1. Our du would be 2 dx, which means we need a 2 over here with our dx, and we'll have to put a 1/2 out front. So this part right here is my u. This part right here is my du, which will give me 1/2 integral square root of u du. I would prefer to write this as the integral of u to the 1/2 du, because that will be easier with my power rule. And now I just need to integrate using that power rule, so I'll have u to the 3/2. Out front, I'm doing 1 divided by that 3/2. Put a plus c on the end. So this is going to give me 1/2 times 2/3 times, I'm going to go ahead and put the 2x minus 1 back in, 3/2 plus c. So that is going to be 1/3 2x minus 1 to the 3/2 plus c. They might change it back to a root or something like that, but okay. Questions? Alright, so that's sort of just like a review. I want us to relate that problem to the new one that we're getting ready to do. So, for this problem, it looks almost the same, but what's the difference? I got this x out front, okay? So, you still only have the option of letting u be 2x minus 1. Anything else is too complicated. Like if you try to let the square root of 2x minus 1 be your u, then your du is going to be way too complicated. So du is still just 2 dx, which means that you need a 2 right here with your dx, which means you'd have to put a 1/2 out front, just like before. But here is the problem that we're going to run into. Right here is my u. Right here is my du. That looks beautiful. But what I'm working with here now, I've got 1/2 integral. That x didn't get replaced. I've got square root of u du. And for me to integrate this, everything has to be in terms of u. I cannot integrate this with an x and a u in the problem. So this x right here is an issue. I need x to become some sort of u. Any ideas on what we could do? Okay, this is so cool. I love these. They're complicated, but it's so cool. All right, so we established that u equals 2x minus 1. That is a fact that we are using to solve this problem. So what we are going to do is we're going to go over here to the side, and u equals 2x minus 1. I'm going to solve this for x. So I'm going to add the 1 to both sides. So u plus 1 will equal 2x. And I will divide by 2. So you can write this however you want. I'm going to write it this way. I'm going to write 1/2 u plus 1/2. Do as you would like. U plus 1 over 2 is fine also. So x equals 1/2 u plus 1/2. And so since that is true, right here, this x can be replaced with 1/2 u plus 1/2. So we're going to do that. It will give us, we need to make sure when we plug it in, we put parentheses around it. 1/2 u plus 1/2. And then I'm going to write, instead of writing square root of u, I'm going to write that as u to the 1/2 power. So now everything is in terms of u. We're okay here so far? All right, so I can't integrate this with those two things multiplied together, but I can very easily just distribute my u to the 1/2. So I'll have 1/2 integral of, this is a u to the first power, I'm multiplying it by u to the 1/2, so that's going to be 1/2 u to the 3/2 power. I'm just adding those exponents there. 1 plus 1/2 will give me 3/2. And then I'll get a 1/2 u to the 1/2 here. It does make for a little bit more complicated integral whenever we get to our u's, but this is something we can do. We know the power rule, so we can do this. We're just going to leave this 1/2 out front, and then we're going to do u to the 5/2, and we're going to divide our coefficient by 5/2. If you can do it in your head, that's lovely. I'm just going to be extra clear. So we're going to get u to the 3/2 here. We're going to divide out front by 3/2. Plus c there on the end. And dividing fractions is easy as pie. 1/2 times 2/5 is going to give us 1/5 right here. So we've got 1/2 times 1/5. And I'm going to go ahead and plug my 2x minus 1 back in here. And then here, that 1/2 times 3/2, or 2/3, is going to give us 1/3 there. So I'll get 1/3 2x minus 1 to the 3/2 plus c. Free response, you can definitely stop here. You don't have to distribute or anything. They may distribute and give you 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. They might do that. So the types of problems that you're going to see on this assignment are going to have this extra x left over somewhere, or something that you can't deal with just using u and du. Because the only thing with u and du, the only thing we can add into the equation are coefficients. We can put coefficients in there all day, because if we multiply by 2, we can multiply out front by 1/2. But we cannot like pull an x out in front of the coefficient. So we can't just pull that x out. So this is going to happen. We're going to have to do something like this when we've got like an extra x left over that we can't deal with otherwise. Okay, questions? Yes. We're just increasing our exponent by 1. So the 3/2, if you add 1 to it, you will get 5/2 for that. So once you get to this point, you're just using that power rule. It's going to be more complicated because a lot of times you're ending up with like fractional exponents or negative or something crazy there, but it's just still that same power. We'll increase the exponent by 1, divide out front by that exponent. Okay, other questions? All right, let's do another one. Actually, do I want to do this? I don't know why that's in this section. Let's do this one. We can live without doing that middle one. It's not really it is a UDU, but it's not this type of UDU. All right, so when we look at something like this, what jumps out as you at you that should be the U? 3x plus 2, because it's inside of that square root. However, whenever we take the derivative of that, we just get 3 dx, which we can put the 3 here pretty easily and put the 1/3 out front. But this part is our U. This part is our du, and right here sits our x that is not replaceable right now. Right? So that's what we're coming up with. When we try to do UDU like normal, we end up with this leftover piece that we can't replace. However, it should be something that we can solve our U equation for so that we can replace this. So you're going to see that most of the time this ends up being x. So if we go over here to the side, and we've got U equals 3x plus 2, we can subtract that 2. We'll get U minus 2 equals 3x. And then we can divide everything by 3. Again, I'm going to go 1/3 U minus 2/3. I just think it makes it a little bit easier to deal with to do it that way, but you can leave it U minus 2/3 if you prefer. So that x right there can be replaced with 1/3 U minus 2/3. So when we substitute in, it's going to look like this. The 1/3 will stay out front. I've got 1/3 U minus 2/3 over. I'm going to write this instead of square root of U. I'm going to write it as U to the 1/2 power. And then we got a du over here on the end. Now that looks pretty complicated to take a derivative with. Oh, not derivative, integral with. What could I do? Because I can't really deal with that as it is. We could move the U up. If we do, what happens to its exponent? It is negative 1/2. Make sure you put some parentheses around your 1/3 U minus 2/3. And then you are going to distribute that. Or the other way you could think of it is like a love connection here. That's essentially the same thing. So 1/3, you're going to have 1/3 U to the positive 1/2 minus 2/3 U to the negative 1/2. All right, is everybody okay here? All right, now we're just down to basic power rule. So u to the 3/2, we're doing 1/3 divided by 3/2. Over here, we're going to get u to the 1/2. We got 2/3 divided by 1/2. And we put the plus c on the end. 1/3 divided by 3/2 is 1/3 times 2/3, which is going to give us 2/9. So we got 1/3, 2/9. I'm going to go ahead and plug the 3x plus 2 back in. And then 2/3 times the 1/2, or divided by 1/2 is times 2 over 1. Which is going to give me 4/3. 4/3, 3x plus 2 to the 1/2 plus c. You might see them distribute that 1/3 back out. You might even see them factor some more stuff out, like they could factor out a 3x plus 2 to the 1/2. That's possible. There's a lot of different ways they could give you that answer. Okay, questions? All right. That's all we're going to do. I think you guys get the basic idea, hopefully. Let me see where the assignment is from tonight. All right. You guys are going to do page 342, 64 through 70. However, number 69 is a super difficult problem. I had to look at the solutions to be able to do it. I understood it once I looked at the solution. Like, I'm not talking like I looked at the answers. I'm talking I had to go find my solution book and look at the solution worked out to be able to do it. I couldn't even work back from the answer. So try it if you would like, but 69 is a bonus question. I will give you 3 points on your test if you can work it out showing work. It is odd, the answer's in the back of the book. You can know if you got it right or not, but it's got to have work with it. I haven't photomathed it lately to make sure photomath hasn't increased its capabilities. I don't think photomath can do it. You have to turn in separate pages, but if you work together, that's fine. And I reserve the right to ask you questions about it if I feel like, oh, the whole class has turned it in, can they really do it? But you're welcome. So if you're working with somebody, make sure you really are working with somebody and know what to do. Not just like, hey, Raven, I got this. You want to copy it down for the extra credit? So I do not mind you working together at all, but you need to know how to do it. If you didn't know how to do it at first and somebody else taught you how to do it, that's perfectly fine. But if you just copy down somebody's work and you have no idea what it is, that I might ask you a question or two. I might ask you to tell me. So 69, save it for last. If you do 69, please do it on a separate sheet of paper so you can turn it in to me so that I can grade those there. So please do it on a separate sheet of paper if you do number 69. Everybody got the assignment? You got about 10 minutes so you can do a problem or two.